Hello, everyone. My name is Teresa. I work for JP Chase as a software engineer, and I'm also a Google developer expert on Dart and Flutter. Today, I will be talking about building a Flutter application on desktop. Few things I'll be covering today. First, we will set up the desktop environment on Windows, Mac OS, and Linux. Then I'll show you some case studies of why we need desktop application and its benefits. Moving on to some app UI like navigation, keyboards, and data storage. In the end, I will show you how we can distribute the application on various platforms. So let's begin. Before we dive in, let's look at some data. So the very first version of Flutter was released in 2018 in London. That was 10 years after Android was released. And in 2019, desktop was first mentioned in Flutter, and through the years up to now, in the recent version 3 of Flutter release, Mac OS and Linux stable version was released. And of course, if you're thinking of building a cross-platform application, Flutter and React Native might be the most popular framework as to now. They are equivalently good and a strong framework for you to choose. But if you are thinking of building cross-platform on a desktop solutions, at the moment, Flutter is the only framework that supply native functions from the framework itself, comparing to React Native, where it relies on partner or community to provide support for Windows and Mac OS. And at the moment, it doesn't support Linux. Just in case you might wonder why we need desktop application. Comparing to web application, desktop application has advantage that you can access it offline, and it's safer to store data. It has better performance, even though comparing to web app, you don't need to install it, but it takes longer to launch. And it's native for desktop. That means it provides you a closer look and feel of your own system. But on the other hand, web app does have lighter on resources. Saying that, there are lots of popular desktop applications we probably use daily. For example, the email app, your IDE, you probably don't want to use online. Maybe you listen to music using Spotify, or watching video, or using Zoom or Slack. Now let's move on to set up our project on those platforms. So first, we'll look at Mac OS. If you're first time using the Mac OS system to build a Flutter application, the very first thing you need to do is to download and unzip the Flutter SDK and add it to your path. And next is you need to install Xcode. And again, if this is the first time you use it, you have to install CocoaPods, which is the dependency management for Mac OS system. After you done all that, you can call Flutter create my app or any name you choose for your project, and then run the command of flutter-run Mac OS. Within a second, you should see the Flutter desktop application loaded on your device. And now we take a closer look of the Mac OS file system. So in your project, you might see a parent folder of Mac OS, and underneath it, there are a few other directories you can find. The Flutter folder has generated files, while Runner has platform-specified code. The other two folders contain source code and dependencies. Then we move on to set up this project on Linux. As you can see, it's a very simple Flutter application, same as building a Hello World application. Again, if you are new to Linux, you have to download and install the SDK and download a bit more of many other tools. I will explain them later, but after you install them one by one. The next thing is to download the Android Studio IDE or IntelliJ or any software that you can find that support Flutter development. And again, similar as before, we call Flutter create my application. Run the app from the IDE. You should see the very first Flutter desktop application loaded on your computer. The Linux project system has a bit different structure and the files comparing to the macOS. Linux uses C++ and a few other tools like the tool that is responsible for infrastructure for the C family. CMake is the cross-platform tool for building, testing, and package. GTK is for UI elements and binding. Ninja is for build system, and then you have tools for compression and decompression. So next, we move on to build the project on Windows. As usual, we download the SDK and add to the system environment variables. Here we need to install two IDE. The first is Android Studio, or your choice of IDE that support Flutter. And next, we need to install Visual Studio and have enabled the desktop development with C++. After that, you can create your app and call run-d Windows. Then you will see your very first Flutter desktop application loaded on your Windows machine. And of course, if you have an existing project that you don't want to create a new from scratch, you can always enable Flutter desktop support on your existing project by calling the command as you see on the screen. Once you call enable macOS -desktop or Linux and Windows, you should see 3 folders was created underneath your project and having all the files you need, same as if you create this project from scratch. And of course, we wouldn't forget about unit testing, right? When we have a project. So do unit testing is same as what we do in most of the Flutter project, unless you want to test platform-specific code. Otherwise, all the tests goes underneath the Flutter lib. So same that you add dependencies of Flutter tests in your YAML file, and you test as usual, run your tests as usual. As you can see, this is the beauty of using a cross-platform framework like a Flutter. So you have to just code once, test once, and then we're going to show you how you can do release once as well. So after we set up our environment, the next thing is to build your project. Your project might have different UI elements, different functions, different screen, different navigation. But if you come from a background of mobile engineering or web, the things that you probably don't deal with very often is the physical keyboard. Do not worry, because all this was taken care of in Flutter. There's a library called physical keyboard key, and what it does, it provides you lots of functions where you can find the key and provide the implementation for that key. Like for escape key, for the key K, or for key H. Once you find the key, then you can implement specific functions you need for that key. And at the same time, you can create a combination of different keys to make shortcuts. So here you have the logical key sets. You can put various keys inside a group, call it a set, and you can provide the functions you need for that key set. This is very handy when you play games or you use some tools, just simply want to use the key instead of using a trackpad or mouse. So if you are familiar with Android development or you have used the Flutter before, to store data locally on device, you can use shared preferences, which is exactly the same as how you would use it for mobile. You can store string, Boolean, or integer, or any kind of number with the shared preferences. But the downside of it is it stores everything in a clear format. So if you want to store something more secure, you can use a secure store. So if you want to store something more secure, you can use the secure storage. Here you need to specify the platform you need. You can use either Windows options, macOS options, or Linux options. Once you declare those variables you need, you can then call it to either write, read, or delete data from your device. But one of the key points here is that secure storage only works for string. So what if we want to store large data, right? So for large data, we can use the file system. The difference here is that the file system directory on desktop isn't as supportive as for mobile applications. Few things that you find available on mobile application, they are not available on desktop. So do check before you use it. You didn't actually create a system error, simply just the file isn't there on your desktop. On the picture on the right side, you can see the list of supported directories. For example, the temporary directory, application documents, and downloads, and application support. They are available on all types of desktop environment. Now we're moving on to the last part of this presentation, distribution, the fun part of all. To distribute your app on macOS, we need to first build the project, right? You need to specify the flavor you want, either it's build or release. And then we need to register the app on App Store Connect, which then you will be given a bundle ID, a unique bundle ID. We create an application record in App Store Connect, do the code assign and the configuration of the application distribution information. In the end, we create a build archive with Xcode. Similar is process on Linux, but on different App Store and a different environment. Here we need to install the Snapcraft with the given command, as you can see on the screen. And we install multipass. Then we build the Flutter app given the release flavor. Then we can build and publish this application on Slack. You have more options to distribute your project on Windows. So first, you can create a file that you can distribute anywhere on a Windows machine, but the downside of it that this might not be the most secure solution, and your user might not be able to get update from your release every time. Another option is to create a package and distribute it to the Microsoft Store. The Microsoft Partner Center manages the whole application lifecycle. You can generate a certificate for private deployment, which, although it's not required for deployment through the Windows Store. So if you think about all this process, they are manual, taking time, and you have to do it repeatedly every time. How can we save our time from doing this, right? So, of course, we can use a CI/CD system, which enables frequent delivery of apps by introduce automation into the stage of app development. So CI stands for continuous integration, while CD stands for continuous deployment. There are various tools that on the market at the moment support Flutter desktop distribution. There might be more, which I didn't put on my screen, but those are very common ones you can find online, like Bitrise, CodeMagic, AppCircle, GitHub Action, or Jenkins. Here I will give a quick example of how you can set up your environment of CCD on Bitrise. Create a project on Bitrise is really simple. You just have to go to the dashboard, connect your repository from Git to Bitrise. Any type of Git account, either it's Bitbucket, GitHub, or any type of Git account. So you have the auto system on Bitrise that help you to enable these settings. And once you have your repository connected, you can make the first initial build. It may be success, it might fail, it doesn't matter. It just shows you that you are connected. And the next is we can start configure the desktop build and deployment system. This is the beauty of using an online tool, because you have lots of pre-made functions, steps, and workflows there for you to select instead of build everything on your own. For example, the Git clone repository, Flutter install, and build the S-code archive mark, right? You can find a lot of Flutter support from all those platforms. There are times you might need to create some manual scripts, right? That's fine. You can actually select script and then add your own script in between. So on the picture, you can see on the right side, this is a very simple step I create for myself in my workflow to enable clone the project from Git, sign it, and build it, and distribute it. So very simple step. Of course, in real life, in your own project, you might have more. You might need more setups and more checks, which is fine. You can actually find the support of most of the things you need a free project from those online tools. Here are some of my thoughts and advice that we can actually improve for the desktop development cycle. First, right, maybe there can be an online IDE for desktop application. And we probably need a better emulator for desktop development. At the moment, for engineers to build desktop applications, an engineer might need at least 2 or 3 devices, right? So maybe we can use a virtual machine, but we need to have the actual machine for Mac, for Windows, and for Linux to build and run the application. It might be a bit troublesome for startup or for any engineers who just want to give it a try. So the next thing I'm thinking, right, maybe there could be some pre-made Flutter virtual machine in a GCP family, like a compute engine we can just download and run it. Maybe there could be a centralized app flavor for desktop. And another good thing we could have is a universal design system that handles all the UI design for Mac, for Windows, and for Linux. So in the end, thanks for listening to my talk. And if you have any questions, any thoughts, and if you tried desktop application, like to share some of your ideas, you can find me and message me. Thank you for watching.